How do computers handle just tons of data? The secret is data structures, especially when you're coding in C.
Yeah, this is the big question, right? How do you manage all that info quickly without bogging things down? Just think about that jump from 16 years down to less than a second. That's absolutely wild.
So what is a data structure really? Basically, it's the computer's super smart way of organizing information.
Okay, let's look at this whole family tree. You'll see it splits into two main groups right away. On one side, you've got your built-in types. On the other, the more complex, user-defined ones you create yourself.
Built-in types are the basics, your integers, characters, and in C, of course, pointers are huge.
Now, over to user-defined structures. In C, you build these with structs. And guess what? They split again. First up are linear structures. And yeah, they're exactly what they sound like. Data all lined up in a row. So what's the big difference? Linear is all about sequence. Nonlinear, that's about how things are connected. And this visual just nails it, right? A straight line versus a complex branching tree. That's the whole idea. Some common linear types are arrays, linked lists, and then there's stacks and queues. Let's look at those. First, let's talk about the stack. It's a linear type with one very specific, very important rule. And that rule is LIFO, last in, first out. The last thing you put on top is the first thing you take off. It's just like a stack of plates. You can only take the top one, right? That's a stack in action.
All right, next up is the queue. It works completely differently than a stack. You could even say it's a lot fairer.
See, a queue is all about FIFO, first in, first out. It's basically first come, first served. The best way to picture it? Just think of people waiting in line. Simple as that. Okay, let's jump back to our chart and check out the other big category, nonlinear structures. Now, this is where things get really cool. Nonlinear structures let us map out more complex real-world relationships. And there are two main types you absolutely have to know: trees and graphs. They're the big ones. A tree is perfect for anything with a hierarchy. Think of a file system on your computer or a family tree. And then you have graphs, which are all about networks. We're talking social media, city maps, you name it. So why do we care about all this? Because picking the right one makes your software fast. Picking the wrong one? Not so much.
So I'll leave you with this. Which of these data structures do you think is running your social media feed right now?